Okay, guys, so today we're going to do 10.1. It's more confidence intervals, so it's going to seem very, very familiar. You guys are still going to use the template that I have got you accustomed to, but the difference is that we have only done confidence intervals for one proportion, one mean, and then we just finished up the difference of means when we had a matched pairs set, and now we're going to do the difference of proportions, okay? So um, this scenario is going to be when we have two different proportions that are in our problem. So our statistic will be that we're going to have two proportions that come from samples. So you'll have a p hat 1 minus a p hat 2. And then your parameter would be that true proportion of number 1 minus the true proportion from population number 2. Okay? If you were to do all of the samples of size n of p hat sub 1 minus p hat sub 2, the true mean would show up in the middle. And the true mean would happen to be the actual true difference in proportions. So your mean here will be the proportions, the true population proportion, the first one minus the second one. Okay. Standard deviation. The standard deviation is still what it was before. Let me move my camera over just a little bit. Except for this time, you have two different proportions in two populations. So here is the equation that you guys are used to. But now we have two. So we have to deal with 2. And there shouldn't be any surprise. We never subtract standard deviations, so there shouldn't be a surprise that that's an addition and not a subtraction. So remember, we're always going to add those, okay? So let's do our very first example. Mr. Wilcox believes that a higher proportion of math students do their homework at East Kentwood High School than students at Caledonia High School. To test his theory, he selected a random sample of 150 students. That's probably going to be useful information, okay? Of the 150 students, 114 report doing their math homework the previous night. On the same day, he selects a random sample of 100 Caledonia students and finds that 62 of them did their math homework. Construct and interpret a 95% confidence interval for the difference between the proportion of EKHS and Caledonia students that do their math homework. So hopefully you guys notice we have two distinct populations. We have the EKHS and we have the Caledonia. And then from both of those populations, we took a sample and we figured out the proportion that happened at each of those in each of those samples. So hopefully that's a little bit clear in your head. I'm hoping that you see that there are two proportions there. So we still need to define our parameters. So let's go ahead and define the very first population. The first population, hopefully we saw that was EKHS, right? So we're going to call this the true proportion of EKHS students who do their math homework. And the p hat for that was that they found 114 out of 150. So I put that in my calculator and I get 0.76. Okay. Try to zoom out a little bit so you guys can see that a little bit better. I don't know if I can do that. Okay. The good news is I'll scan these in so you guys will have access to those also. Okay. The second proportion or population was when we talked about Caledonia. So that's going to be the true proportion of Caledonia students who do their math homework. And again, when we did that one, we got a sample of 100 and there were 62 of 100 that did their homework. So put that in your calculator. Hopefully you don't have to put that one in your calculator, but you get 0.62. So we would like to do P sub 1 minus P hat sub 2, which means we're doing 0.76 minus 0.62, which if we put that in our calculator, we get a difference of 14%, right? So we are going to go ahead and construct a 95% confidence interval. So before today, we had a 1 proportion Z interval. Well, how many proportions do we have? Hopefully you see there are 2. So there shouldn't be a surprise when I say the name of this test is a 2 proportion Z interval. Okay? So your conditions are still what they always have been. We still have random, normal, and independent. The difference is that we now have 2 distinct populations. So we have to check these for EKHS, and we also have to check these for Caledonia. So I literally just do them side by side. Okay, so I'm going to go ahead and check normal for both of those, and I was nice to myself and highlighted them up here. So for EKHS, we selected a random sample of 150 students. So down here in random, I'm going to say random sample 150. And for Caledonia, we had a random sample of 100. Okay, now we're in proportions, so we check normal one way. We have NP greater than or equal to 10, and we have N times 1 minus P greater than or equal to 10. So we're going to do that for both of these. There were 114 successes that said they did their homework, which means we have 36 that don't, so that checks off. If we go over to Caledonia, there were 62 that said they do their homework, which means 38 would not. And so because of that, we could go ahead and say that the sampling distributions are going to be approximately normal. Remember, that's that holistic bump. Okay. And independent is still checked the same exact way. We want to make sure that that population is big enough, but then not too big. So we want our sample to be less than or equal to 1/10 of the population. So we could check that. In this scenario, we could also probably say that EKHS students' homework results are independent of Caledonia. Surely the students over here are independent from these students. That's another way to do that. So So then we're going to do our math box. We are still doing a confidence interval. Okay, I'm going to slide this up just a little bit. So we're still dealing with the estimate plus or minus the margin of error. Okay, so our estimate, we talked about that. That's going to be that difference of p hat 1 minus p hat 2. That's our estimate, plus or minus the critical value, which is a z, and the standard deviation of the statistic, Okay, so we're going to plug those numbers in, and then we could simplify it down, or we could use our calculator. So if we plug our numbers in, oops, not a parenthesis there, 0.62 plus or minus, I'm doing 95%. Hopefully we have that memorized. Our z-score is 1.96, 0.76, oops. I wrote this wrong. This is a 0.76 here. I wrote that wrong as a 7.2. 0.76 times 0.26 over the sample plus the 0.62 times the 0.38 over the sample. And if we do that, we get 0.023, 0.257 as our interval. I am going to do this verbally, but it is on my notes if we conclude. We are 95% confident that the interval from 0.023 to 0.257 will capture the true difference proportion, p hat sub 1 minus p hat sub 2, of EKHS students and Caledonia students who do their homework. Okay, and guys and gals, you can do this on your calculator. So you're going to go to stat test, and then you're going to look for the 2-prop z interval. So if you go down here, you've got a test. You don't want the test, you want the interval. So there's a z interval. You have a 2-sample z interval. Okay. You also have a 2-prop z interval. So we want to use the 2-proportion z interval. Notice that you have xn, things of that nature. You can't do decimals in here. Okay, so you need to have counts. Like EKHS was 114 out of 150. And Caledonia was 62 out of 100. Okay. Oops. I hit enter too many times. Okay. And notice you get the same interval that I had here. Just realize that if you go to put decimals in for your x, it's going to give you an issue. Okay. So you can do that on your calculator. Okay. Last example. I actually want you to try this one by yourself. Okay. Go ahead and try this one by yourself. You're going to construct and interpret 90% interval. So your critical score, your critical value will be different on this one. Try to do this one, guys, without looking at my notes, and then go double check it with your notes. Okay. Use your very first one here. It's going to follow the same format. Okay. So it's going to be a 2-proportion z interval. Go ahead and try to mimic it on this one, and then check it off of my notes. Okay. When you are done with your notes, you should be able to start your homework. You have that page 622 that'll be due this week.